Hi, fabulous fourth graders. Today in this online video, we are learning how to find equivalent fractions. When I see this word equivalent, it sounds to me a lot like the word equal. Okay? Let's learn about what equivalent means. Okay? If we are working with the fraction 2/3, okay, we know that we can draw a model to represent 2/3. I'm going to choose to do an area model. I need to split it into thirds since my denominator is 3. If I shade in 2/3, I would shade in 1/3, 2/3. Okay. When we are finding equivalent fractions, we are looking for a fraction, okay, that represents the same part of the original whole. So we want to know, what is something else that is equal to 2/3? One way that we can do that is by drawing another area model. This time I'm going to choose to, I'm going to split it into 12ths. So I'm going to do my thirds first. I know that 3 times 4 is 12, so I need 4 parts going this way. If you think back to our area models, when we learn modeling multiplication, we know that if there's 4 going across this way, 3 going down, 4 times 3, I must have 12 total boxes. Excuse me. Now, if I shade in the same amount in this model as I did in the other, I will end up with an equivalent fraction. Let's see. I know there's 12 total parts. That's my denominator. How many units did I end up coloring in? 1, 2, 3, 4 12s, 5, 6, 7, 8 12s. We just found that 2/3 is equivalent to 8 12ths. Okay, our models support that. They are equivalent. Okay, since I changed my model from thirds to 12ths, I know that 12ths are smaller units than thirds. And so I needed way more 12ths to be the same as 2/3 since my individual units are smaller. I could now take a look and say, all right, but do we, I'm sure you're all wondering, do we have to draw a model like this every time we need to find an equivalent fraction? The answer is no. Let's learn the steps for finding an equivalent fraction without a model. I want to work with my same fractions again, my equivalent fractions, and I'm now going to study and look at what happened here. I want to think about a multiplier, okay? Something that I could multiply this 3 by to turn it into 12. If we think about our facts, 3 times what is 12? 3, 6, 9, 12, 4. 3 times 4 is 12. If I use that same multiplier up here with my numerator, I multiply the denominator by 4, I'm going to multiply the numerator by 4. That gave me 8. 2 times 4 is 8. 3 times 4 is 12. So if we wanted to determine if 2 fractions were equivalent, or if we wanted to find a fraction that's equivalent to another fraction, we can multiply the numerator and the denominator by the same multiplier, and it will give us an equivalent fraction. Before we practice more, let's take some notes in our workbooks. If you do not have your workbook with you right now, that's okay. Please pause the video, go get your workbook, and come on back to us and hit play. If you have your workbooks right with you, please open up in your workbooks to page 307, 307. All right, we should be ready to learn. We're on page 307, number 1, working with equivalent fractions today. Louis said to Maria, 8 bags is 8/12 of the 12 bags you wanted to sell. I think 2/3 is the same as 8/12. I can show you why. And Louis made this drawing. Did Louis earn his pay? Explain your answer. So the question is, are 8/12 and 2/3 equivalent? Let's take a look at the model that he drew. Okay, he made 2 candy bars. Notice they're exactly the same length. He split the first one into thirds and he shaded in 2/3. Okay. Then he split the other candy bar into 12ths. Notice that the pieces are much smaller since we needed to divide that whole into 12ths. They had to be smaller. And he shaded in 8/12. Are they equivalent? Well, since they're the exact same length, we can say yes, they are equivalent. Let's check the rule we just learned on the whiteboard. What would you multiply the 3 by to turn it into 12? 3, 6, 9, 12 times 4. So if we did the same to the numerator, we get an 8. That means these 2 fractions must be equivalent because when we multiply them by the same multiplier, or you could think of it as the same factor, okay, we end up with an equivalent fraction. Here's what we're going to write for our notes. Yes, each third is the same size as 4/12. So in this third, we have 4/12. In this third, we have 4 more 12ths. Put together make 8/12. So 2/3 is equivalent to 8/12. Moving along, it says 2 fractions that represent the same part of a whole are equivalent fractions. 2/3 and 8/12 are equivalent. Number 2, Maria says, you're just factoring each third into 4/12. You can show what you did using numbers. And again, this is rewritten what we've already talked about here, and on our whiteboard. Discuss what Maria did. How does multiplying the numerator and the denominator by 4 affect the fraction? Let's write in our notes. We multiply both by 4, which makes an equivalent fraction with smaller unit fractions. It just means that that equivalent fraction is going to have more units to it because the parts are smaller. You need a whole lot of 12ths to be the same as just 2/3 because the parts are smaller. You're all doing awesome. If you need more time, pause the video to write that. Let's move along to the next page. They now give us a whole bunch of fraction bars, and it says, how do these fraction bars show equivalent fractions for 1/3? Well, we can use the visual to help us. Let's start by writing 1/3 equals. Look at just the sixths. How many sixths do we need to equal a third? 1/6, 2/6. Now let's figure out what their multiplier was. 3 times what is 6? Hopefully you're at home saying 2. If we multiply the denominator by 2, we have to multiply the numerator by 2. So if they did not give you these fraction bars and they said, all right, list equivalent fractions for 1/3, you could choose the number 2, since most of you are good at multiplying by 2. Multiply top and bottom by 2, and it would have given you that equivalent fraction, the same one you found with the model. Now we want to know, okay, well, how many ninths are equal to a third? Please go down here and count. What would you answer? Hopefully you're saying 3/9. Now, We cannot build off of this equivalent fraction. You always have to go back to your first fraction that you start with when you do your multiplying. So in this case, it's not, okay, 6 times what is 9? You'll be stuck because 6 times nothing even is 9, right? So if we go back to our original fraction, we're now asking ourselves 3 times what is 9? It's times 3, right? So if we multiply the denominator by 3, we multiply the numerator by 3, and that's how we ended up with 3/9. Another equivalent fraction, how many twelfths? 4/12. Same thing, let's go back. 3 times what is 12? It's 3 times 4. So 1 times 4 is 4. Okay, we could keep going, but we're going to pause for now. Lots of repetitive practice. Let's jump all the way down in our workbooks to page 308 at the bottom. A, B, and C. These 3 problems are what your assignment today are going to look like. Here's what they'd like us to do. Tell whether the fractions are equivalent. So it's a yes or a no. Okay. Is 1/6 equivalent to 2/12? Here's how we're going to figure this out. I'm going to give myself some space. So I'm going to rewrite those 2 fractions. And now I'm going to sit and think. Is 6 times something 12? Can I multiply 6 by something even? So no decimals or getting creative, an actual whole number. Is 6 times something 12? Yes, my brain is telling me it's 2. 6 times 2 is 12. If we multiply that denominator by 2, we have to multiply the numerator by 2. Is it correct? Is 6 times 2 12? Yes. Is 1 times 2 2? Yes. Since we multiplied the numerator and the denominator by the same multiplier, okay, and we got the second fraction that the way listed, we would say yes, they are equivalent. Letter B. 3/6, I'm rewriting just so I have space, and 5/9. I always start in the denominator. Is 6 times anything 9? Well, when I think about skip counting by 6s, 6, 12, 18, 24, 30. No. 6 times nothing is 9. 3 times nothing is 5. No. These 2 fractions are not equivalent. Another way to think of it is 3 is half of 6, so this is equivalent to a half. 5 is not half of 9. No. Take a look at this next one. Rewrite it so I have more space to work. We always start in the denominator. Is 12 times anything 15? No. Is 6 times anything 8? No. No, these are not equivalent fractions. Again, 6 is half of 12, so something that is equal to 6/12 is a half, and 8 is not half of 15. No. I just did all that out loud thinking to show you another way to think of it. No, they are not equivalent. You'll be practicing this more today on your assignment. Thank you for working so hard, and thank you for tuning in for the entire video. Continue to please be responsible and take pride in your work. Your hard work is paying off. I miss you all lots, 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 and I hope you have a great day. See you soon.